All right, salam alaikum, fellas. We're moving on to exercise 12, verse 7. So simplifying algebraic fractions using multiplication and division. Firstly, we're just going to begin with how we're going to deal with just normal fractions and how we can simplify them. So the reason we did so many of those previous exercises and why I spent so much time on them is because that's all leading up to questions like this. So you will see just how much you need to be familiar with all your techniques. If you recall, we have those 5 techniques. Let me just pull them from here. So as you can see in the previous exercise, I'm actually going to pull them from here. All right, so we've got those 5 techniques. You need to identify each technique when you're doing algebraic fractions as well. So for example, if I look at the first problem here on the examples, then I can see that this is a common factor in the numerator. So I'm going to use the common factor technique. So before you start the question, you might want to label it. So this here is common factor. You can write 1 as well, but I'm not going to write numbers just in case it gets confusing. But that's definitely a common factor. So let's begin that. And as I can see, there's nothing I can do with the bottom. That's just a number. So what I do is I begin the factorization. So the numerator becomes 5 bracket x plus 2 because we can see that 5 is common to both 5 and 10. By now, I shouldn't have to explain that anymore. You guys should be aware of that or know how to do that since we've done so many exercises on it. And then we just write what's left behind. So we had the 5 left behind, write that there. And now there's a condition for doing this. You're not allowed to have any pluses and minuses outside of brackets. So it's okay inside of brackets, but if there was a plus or a minus here, I'm not allowed to do what I'm about to do. I'm allowed to divide the 5s. And the rule is you can't have any pluses or minuses happening outside. That will make more sense as we move along. But as you can see, the 5s here will actually divide each other because 5 divided by 5 is 1. And then we're just left with x plus 2. And that's my answer for the first example. Okay, now the second example. First, identify the types of factorizations you're going to use. In the numerator, I only see common factor again. So that's a common factor. In the denominator, I don't see any other technique except for common factor again as well. So this time, I'm going to be factorizing both the numerator and the denominator. So here, in the 3a plus 9, I can see that the common factor will be 3. So I'm left with 3 bracket a plus 3. In the denominator, I can see the common factor is 6. So we have 6 bracket a plus 3. And this time, as you can see, so again, we don't have any pluses and minuses in between the terms outside of the brackets. But what I do have is I have identical brackets. And this is extremely satisfying. When you have identical brackets and there's no pluses or minuses outside of the brackets, you can actually cross the entire thing out. Okay, and so I'm left with 3 over 6. But we all know what we can do with 3 over 6. That will simplify to become a half. And that's our final answer there. So that result there actually becomes half when fully simplified. Another thing, because I like to do multiple things at once. Maybe you guys should, maybe you should do it the way I just did it, like write 3 over 6 and then simplify to get a half. But reality is, when I see 3 over 6 here, I can actually simplify it straight from here as well. Because 3 divided by 6 is going to give us 1 over 2. So I can write like this. And then on the very next line, I can write my answer half. Just like that. Okay, so these are just some of the ways that we can approach our problems. Remember, there's many ways to the final answer. You just have to figure out the way that suits you and go from there. All right, so let's look at the next example. And here I can see something interesting. I've got a quadratic trinomial here, and I've got a monic trinomial to boot. So it's a monic trinomial because we can see that the coefficient of a squared is 1. So monic trinomial, I'm just going to label that. And once I figure out what I'm going to do with that, I'm going to factorize. With the denominator this time, I can't do anything. So I'm going to leave that. So with my monic trinomial, I can see we have a sum of -3 a product of -4, and I can tell you that the two numbers are -4 and +1. So that means with monic trinomials, you can actually answer that straight away. So a -4, a +1 over a +1. Now, if you notice, this and this are identical, and there's no pluses or minuses in between the top. So guess what? We can factorize, so we can simplify like this. And therefore, I'm just left with a -4. And that's it. That's my answer for that example. So even if you put a quadratic trinomial in the fraction, it can actually be easier, as you can see in this case. So that's the introduction to simplifying algebraic fractions. We're going to move on to some harder questions. Now, as you can see, they can get quite complicated. So let's take a similar approach. I'll need my rules. So let's take these rules. Bring it down here. And I'll just pop the rules down here somewhere, so we've got something to look at. So again, we go with a similar approach. All right. Now, what I do, I look at every single part of the fraction. If the way I see 4 things: 1, 2, 3, 4. That's what I look for, and then I start here. What technique can I use here? And that one's easy. That one is common factor. Then I look at the other one. Can I do anything with this? No. Can I do anything with this? No. Can I do anything with this? No. So what we'll do, we'll start with this one. We'll factorize it. We get 2 bracket x plus 2 over 3 times 6x over x plus 2. Now, one thing that's really nice about multiplying fractions is we can actually cancel things out from different fractions only when it's multiplying. So for example, see this x plus 2? This will actually cancel out with this x plus 2. All right, the reason is because of the next line I'm about to draw. Okay, so sorry, let me start that again. The reason I can cancel out is because if we look at the rules of multiplication of fractions, then all we have to do is multiply things straight across, don't we? So that means I can multiply 2 and the 6x, that will give me 12x. And the bracket, I just leave it, I don't touch the bracket. And in the denominator, I combine these two, so 3 bracket x plus 2, just like that. And then from here, you can see that you can clearly cancel out the x plus 2. On top of that, I also have 12 over 3, which can simplify to 4 over 1. And now, everything that hasn't been crossed out is my answer, 4x. In theory, we could have done that on this line. So watch what happens if I do it from this line. Let me just copy paste a duplicate of this here. So theoretically, what I was trying to say is I can actually cancel the x plus 2 in this state when there's a multiplication in between. And then if you look, 6 over 3 is 2 over 1. And then everything that's not crossed out combined. So look at that, 2 times 2 times x, which will also give 4x. And as you can see, it's the same result. Like I said earlier as well, there's more than one way to an answer. You figure out what you like, which approach you prefer. If you like to combine first and then simplify, go ahead with that. That's the way I'll be showing all the examples, combining and simplifying, because I feel like it might be you might be less prone to mistakes that way. Okay, so let's remove that. And now, let's start the next example. So, like I said earlier, identify all the techniques you're going to use. Here, I see nothing but a common factor. Here, common factor. Here, common factor. And here, common factor. Sometimes, you see common factor for everything, as I just saw here. It all depends on what is going on in that problem. Okay, so from that, we're going to apply all the rules that we've just identified. So the first one, notice I'm going to look at everything like it's its own question. You're essentially doing 4 questions in one. All right, so here, what's common? We have y that's common. And remember, when you completely factor out a number, then you replace it with a 1 over 2y plus 4 times, here the common factor is 2y plus 3, and over here the common factor is 3y plus 1. All right, I think maybe I should show, I can rewrite and combine everything, but I think it's best to know that if this is a multiplication, then I can cancel out from opposite fractions like this. Okay, and I think that's everything. Everything that's left behind, and I'll highlight it to make it clear, this will be our answer. And just write it in a neat way. So I like to usually write single terms outside on their own. So if we look at the numerator, we have y times 2y plus 3. So I'm going to write y bracket 2y plus 3. And in the denominator, I have 3y plus 4. So I'm going to write the 3 first, y plus 4. It's just more aesthetic to write the single terms on their own first. And believe it or not, that's the answer. You can't do anything else with that. All right. All right, now the next one. If we look, which technique are we using here? Monic trinomials. So this is a monic trinomial. Let's look at the one underneath. That is also a monic trinomial. Let's have a look at the next fraction. Monic trinomial. And the next fraction, another monic trinomial. So this one, just like the previous question, has all 4 of the same technique, except this time it's all monic trinomials. So take your time. There's no need to rush. The need is to be perfect. So let's have a look at the first at the first expression here. We have a sum of 6 and a product of 5. So the two numbers that add to 6 and multiply to 5 are 5 and 1. And when I figure that out, I can just write x plus 5, x plus 1. That's done. So that numerator is done. Let's look at the next denominator. So here we have a sum of 5, a product of 4. So what two numbers add to 5 and multiply to 4? And that's easy. That's 4 and 1. So we get x plus 4, x plus 1. Okay? Let's move over to the next fraction. We can see here that the sum is 7. The product is 12. And that's easy. The sum of 7 and product of 12, the numbers are 3 and 4. So straight away, with monic trinomials, you just write x plus 3, x plus 4. And then finally, let's look at this fraction. We have a sum of 12 and a product of 35. That is 7 and 5. So 7 plus 5 is 12, and 7 times 5 is 35. So you write that straight away as well. And now the fun part. We start cancelling out because of division. Whatever's on top and is at the bottom as well, they will cancel each other out. So first thing that's obvious is x plus 1 divided by x plus 1. They will cancel each other out. We have x plus 5 divided by x plus 5 in the other fraction. They will also cancel each other out. And in this fraction, we have x plus 4. And in that numerator, we have x plus 4 as well. And then everything that's left behind is your answer in that order. So you have to make sure you maintain the fraction. So x plus 3 is on top. X plus 4 is on the bottom. And there we go. That's the answer for that example. All right, so now we're moving on to some seemingly more difficult questions. But I assure you, if you're able to identify and factorize correctly, these are not difficult at all. So let's begin. Here in this numerator, we have a difference of 2 squares. All right, as you can see, that's a squared number, that's a squared number, and they got a minus in between. So that's a difference of 2 squares. Here we have a monic trinomial. Here we have a monic trinomial. And here we have a monic trinomial. But you may have noticed something. There's a division here. Well, if you recall, The division's trick is to flip this fraction. Okay, that's all it is. Just flip the fraction and redo it. So let's rewrite the question. And we're going to change it to a times, and we're going to flip these. So that means I'm going to write x squared minus 3x minus 10 on top. And on the bottom will be x squared minus x minus 6. Now just correct your labels. They're all, on this fraction, they're both monic trinomials. This is a monic trinomial. It's just the difference of two squares that's different here. All right, so now we're ready to go. It's just like the previous question. So division, there's nothing really to it except to just flip the fraction after the division sign. Flip that and then continue it as a multiplication question. All right, so let's go ahead. Let's factorize that. We're going to get x minus 2, x plus 2, if you remember how to use the difference of two squares. This denominator is a monic trinomial. So that's a sum of -7, a product of 10, a positive 10. So that's minus 3, minus 4. Sorry, minus 2, minus 5. We've got another monic trinomial here, a sum of -3 and a product of -10. That is x take away 5, x plus 2. And over here, everyone gets tricked by this. When you see an x, just imagine there's a 1 in front of it. So therefore the sum here is -1, product of -6. So -1, -6 is minus 3 and positive 2. So x minus 3, x positive 2. And there we go. Now we can start crossing things out. Now you're only allowed to cancel out 1 for 1. So what that means is, you see how there's x plus 2 here, but then there's two x plus 2's in the numerator. You have to only choose one of these ones from the numerator to cancel out with this. You can't cancel out both. Only 1 for 1. So if we look here in the over here, I'm just going to cross this out. I cross those two out. I'm not allowed to cross this out now. There has to be another x plus 2 in the bottom somewhere to be able to do that. All right, let's continue cancelling. We have x minus 2 divided by x minus 2, which is 1. We have x minus 5 divided by x minus 5, which is 1. And then we're left with x plus 2 over x minus 3, which is the answer. And there we go. That's literally it. All right, let's look at the last example now. So over here, we can see there's a division sign. So the first thing I'm going to do, I'm going to rewrite the fraction. And I'm going to change the division to a times. And then we're going to flip the fraction. And there we go. So now we're ready to identify all the techniques we've got to use. So in the first one, if you notice, this is a bit unique. This is one of the hardest questions that you're going to face. But I have 4 terms here. 4 terms always means grouping in pairs. Grouping in pairs. So that's the first one. All right, here I have 3 terms. In the denominator, we have 3 terms. So that's back to a possible trinomial. Tri means 3. So therefore, this is a monic trinomial, but it's a little bit different as we've got these y's here as well, but I'll show you how to deal with that. And then we have 2x plus 2y, which is a common factor. And then down here, we've got 1 plus x minus y, which I can't do anything with. So there's no factorization happening there. So let's begin with x plus y plus x squared minus y squared. Now, believe it or not, this grouping in pairs has 4 terms, but I can't even do anything with this first term, with the first 2. There's nothing I can factor out except a 1. And on that, do it. If you can't do anything to a grouping in pairs situation, just factor out the 1. And if you can't do anything to the second pair, well, guess what? This is a very unique situation. If you notice, this is actually a difference of 2 squares. All right, this is one of those harder questions. These two here, you use difference of two squares on it, and you'll see what happens. All right, if you notice, I now have a common factor of x plus y. Now that is a very advanced question, so those of you who are really going to push yourself to the highest level, you have to know how to do this. So let's highlight this. This is going to be our common factor on the next line. So I still have factorization to do. There's a lot of work still to be done. All right. Maybe we'll finish this off. So I'll finish it off in preparation for the next line. Like I said, these two are common factors. We have x plus y as so the yellows combine as one factor. And then in the brackets, I write down everything I left behind. And as you can see, I left behind 1 plus x minus y. So we're going to put that in the bracket. And you may have noticed something as I wrote that. Well, there you go. So I just wanted to deal with that first because it's very hard. Because sometimes the way you look at it, it's like its own question. And I just wanted to deal with that first before I moved on. All right. Now let's come down to this monic trinomial. This monic trinomial is very weird. So we have a letter here and a letter here, so that can confuse things. But where it becomes easy is notice that there's no number on this. There's no number on this either. Well, guess what? You don't need to put any numbers there. Imagine there's a 1 here. So all you got to do is focus on the numbers. What adds to 2 and multiplies to 1? And that's pretty straightforward if you think about it. That's just 1 and 1. 1 plus 1 is 2 and 1 times 1 is 1. So that means my brackets will actually be x, and then normally I'd put a 1, but there's a letter here this time. So instead of putting the 1, I will put the letter instead. And both of them are plus y, because there's no minus here to make it negative. So there we go, that's that denominator factorized. And I'm going to rewrite it here again. All right, let's move on to this one. So times, you can see in the numerator here, that's a common factor of 2. And like I said earlier, that denominator, we can't do anything with it. So 1 plus x minus y. This will become a bit more easier to deal with in the next line. Because my next line is fully factorized, see, if I try to cancel out here, I might make some mistakes. Because you notice there's a plus. Do you notice there's a plus here that isn't in a bracket? That's kind of what I was saying earlier. You can't have pluses and minuses in between brackets. If they exist, you shouldn't be cancelling. But now in the next line, this line that I'm about to write, you will notice there's no pluses or minuses outside of brackets. Even this is considered a bracket. But there's none anymore, and I can start cancelling out. So let's have a look. Let's start cancelling out. We have x plus y, x plus y. There's another x plus y. I can't cancel that out yet. But guess what? This question is the perfect example. There's another x plus y here, so I can actually cancel out these two. And then finally, we have 1 plus x minus y over 1 plus x minus y. So there's a triple, there's a term with there's an expression with 3 terms which cancel out as well. And then you can see the answer clearly. It is this 2. So therefore, this is one of those situations where math students say, oh, all of that for just 2 or 1. Well, yes, in this case, all of that just for 2. All right, so if you're, while you're doing your questions, if you need to go back to anything, feel free to take screenshots, rewind the video. Just make sure you're understanding it before the next lesson in person, because this is a hefty topic and this is essentially your true introduction to high school maths. So guys, get going with that and I will see you soon. Assalamu alaikum.